11.2, which you're probably really concerned or questioning why we're going backwards now from 11.3. I wanted to introduce you to radical equations first because they're a little bit easier to solve. 11.2, however, is more important in geometry because we're going to be using square roots a lot in geometry. This section, the assignment, you must know how to do each of the homework questions. Very, very, very important. What we're going to be doing is we're going to be simplifying radicals. Here's some of the rules for it. You can put these in your notes. You can put them if you want to write them down. That's up to you. I'm going to just be showing you guys how to solve these questions here. A couple things. If you have two numbers being multiplied underneath the radical, you can break them up. But, and then the other thing is if you have two radicals, and the reason why you do that is so that you can simplify one of them. So for example, you break this up into 4 and x, and the square root of 4, we know that is 2. So that allows us to simplify. And vice versa, if you have, let's say you had like 6 and let's say 3, you could put this together to get root 18. Now why you'd want to do that is because then you could break up root 18 into root 9 and root 2, which simplifies to 3 root 2. So if there's two radicals being multiplied together, you can multiply the two numbers together inside and then further break it up. So that technique is going to be used later on. Okay, let's get right to it. Root 32. I'm actually going to do this on a separate page here. Root 32 and root 9x cubed, and then show you how we approach these problems. So root 32, you're going to be looking for your perfect squares. 4, 9, 16, 25, 36, 49, etc. We can keep, we can do this, keep going. But these are the perfect squares. The reason why they're called perfect squares is because if I square root any of them, take any of these, they're going to give you a nice whole number. So you can square root all of those, they're going to give you a whole number. All right, so what you want to do is break up this 32 into one of these numbers that can be multiplied by another number. In this case, 16 times 2. 16 times 2 is 32, and 16 is on my list right there. So root 16 is 4. 4 root 2 is my simplified answer. I cannot simplify 2 anymore, so that means I'm done. If the number inside simplifies further, you need to continue. For example, if you had done, you might have said, well, 32, isn't that really 4 times 8? Yeah, it is. 2 root 8. However, 8 simplifies into 4 and 2. So it's 2 times root 2, which is 4 root 2, which is the answer that we had gotten before. So try to choose the largest perfect square, in this case 16. That divides out evenly. This one here, we're going to break up into 9 and x squared and x. Now, anytime you have, and I'm going to do another example very similar to this. Square root of 9 is 3. The square root of x squared is x. The square root of x is the square root of x. We don't know what that is. I'm going to show you a slight variation of this so you kind of have an idea. Oh,
Attention staff.
Sorry.
Please report to the cafeteria.
Okay, sorry for that pause in the video. Okay, 9x to the, say, 7th. So how you approach a problem like this? Very similar. You want to break it up into pairs. The x to the 7th is really x. So x to the 7th, we go back to exponents from last year. 1, 2, 3, 4, 5, 6, and 7. This is what x to the 7th looks like. So what we want to do is we want to split up into pairs. And the reason why I split up into pairs is so that this is x, and this is x. And then I'm left with the square root of x. So this is 3x times 3 times x to the 3rd root x. And that's the approach when you have a variable to a power, you want to split it up into 2's. Sometimes if it's an odd number, you're going to have an x left over. And if it's even, you won't have this. So, okay. Multiplying radicals. This is that skill I mentioned at the beginning of the video. If you have something like root 6 times root 6, you can multiply those together. Anytime you see two roots, multiply them together first. It's going to make the problem easier. So here I have root 3x times 4 root x. The 4 is on the outside. Leave that on the outside. And then you have 3x times x, which is 3x squared. And then you can break it up. root 3 root x squared. Now root 3 does not simplify. If it could, we would simplify it. So I have 4x and then root 3, because this right here, this is just x. Alright, one more problem on this slide here. The 3 is on the outside, I'm going to leave that on the outside. Then you have 7x y squared and then x. All of this stuff underneath the radicals can be put together, multiplied together. So that's going to be really x squared, I guess. So x squared, y squared, and then I can break this up. Root 7 doesn't simplify. Root x squared and root y squared, though, will simplify. So we're going to have 3xy root 7 as my final answer. And if you want to see it all written nice and neat, there you go. Okay, when you're doing division of radicals, you're simply just going to take the square root of the top number, take the square root of the bottom number. So for this example, you can take the square root of 16, which is 4, take the square root of 25, which is 5. And I'll show you guys a couple examples here. So we're going to split this up. Root 13, root 100. Root 13 doesn't break down, so it's just root 13. Root 100 is 10. Same thing on the bottom. Root 7 over root x squared. Root 7 doesn't simplify. Root x squared is x squared. See if we got anything else here. Yeah, I think we're good on that page. And that should be enough information for you guys to get through this. Like, I can't stress this enough. You need to do all of these problems. If you don't understand one of them, you're going to be missing out on a concept that could cause problems later. So please give all these problems a attempt and ask questions on the ones that you are missing or you don't understand, because they're all slightly different. Thank you guys for tuning in. Appreciate it.